Hey everyone, and welcome back to another session on logging in Zephyr RTOS. In the previous video, we covered the key file needed to set up logging in Zephyr, including device tree overlay to show how to modify hardware configuration file for setting up logging level and enable logging, build system to ensure how everything is linked, and logging implementation. So we write and test different log levels. So in the previous video, we didn't go through lot details, but today we're going deeper into logging. We'll explore how to filter log messages efficiently, the different logging modes, for example, default modes, intermediate modes, or minimal mode, and what's happening during logging panic, and how log panic works. By the end, we'll have a complete understanding on logging in Zephyr. In Zephyr, logging messages are classified into different severity levels. These levels help in filtering so that we can focus on the most important messages. Here's a quick breakdown. Log error that indicates critical failure that need immediate action. Warning indicate potential issues that may require attention. Information that provides system status updates, and at the end, debug used for troubleshooting and development. Each of these files can be used in different scenarios, ensuring that we capture the right level of detail in each logs. Now let's dive deeper into how we use these logs level in Zephyr. Zephyr provides different micros for logging, depend on what we need to log. For standard logging, we have log underline X. For raw data, for sending raw data through log, we have log underline hexadecimal, and we also, for sending messages that associated with the particular instance, we have log underline instance something. Here we can, here I will show you how to use each of these macros. Okay, let's see how to use uh, these macros in Zephyr. So first we need to register a log named main. So I would use log underline module register named main with the debugging level. So log underline level debug. And for example, let's send sorry, int x equal to ff, and let's send this x to the module, so to the log. So let's use hex dump as a, for example, debug. So first parameter is the pointer to the data, so we can send x, then the size of data in byte. So size of X, and then we need to um, send a string, a string. So X is this. Now we would like to build and flash our board. And then flash, and then let's see. Okay, let me clear this and reset my board. So X is equal to FF. This is how it looks like. So this is it. Okay, now let's see how to use instance in logging. So first we need to uh, register an instance. So log underline register, then the name of the module, and then the name of the instance. So for example, log underline instance, then the level of the instance that we want to use. So log underline level underline, for example, debug. Then we need to declare a pointer to the instance. So instance underline ptr underline declare. So here we need to use the log instance name instance. Now I define a micro. I define a micro, for example, log underline instance ptr that is underline ptr, and then name of the module and name of the instance. Log underline instance. Uh, then we can use the, for example, log underline inst underline, for example, inf, then the pointer to the instance. So this pointer, then the a data that we want to send, for example, this is um, logger instance. Then again, build and flash the data, the code. So open terminal. Remove the previous build and build the code. And then flash it to the board. So, how we see it? We see the module name, then the instance name, and then we see the mm, information that we send to the logger instance, and we see that this is an info. In Zephyr, logging is controlled using Kconfig options. The most important ones are config underline log that enable and disable logging. It turns the logging off and on. We also have configuration for different mode of operations. For example, deferred mode, intermediate mode, and minimal mode. The deferred mode is the default mode that is better for performance. It's like a thread in the system that has a low priority. The other one is intermediate mode that logs will be sent immediately and it's useful for debugging crashes. The other one is minimal mode that uses minimal footprint logging. We have the other micro in logging that name logging underline panic. In a critical failure, Zephyr cannot rely on normal mechanism. Instead, it enters uh, to the panic mode, where logs are flushed immediately. These force all the logs to be printed before the system crashes. We also have Printk that is similar to printf and it is enabled by default. It is faster and simpler than uh, log messages, but it doesn't support log structure and filtering uh, logs. Uh, but and the output may crash if unless you set the config log printk to yes. I will show you how to use printk. Okay, let's see how we can use Printk in Zephyr. So first thing we need to do is to enable a Printk. So let's go to the conf.conf file and enable Printk. It's already um, enable, enabled by default, but let's do it. So maybe sometimes you need to disable it. And then define a variable. Hello world, new line, and then as you can see, it's quite similar to printf. This is x equal to this and new line. Save and let's build and flash the code to the board. Okay, I forgot to add x here. And then flash the code. Um, let's see. Yeah. Hello world, and you can see that x is equal 10 is printed. Now, it's good to know that logging in Zephyr consists of three main parts: front end, core, backend. Front end capture logs and prepare them. Core processes and manages log messages. And backend outputs log to different destination. Uh, Front end is responsible for handling log messages as quickly as possible. It filters logs, it allocates memory, and it works fast even in interrupts. We also have core, that is the brain of logging system. The core is responsible for processing logs and dedicate where they go. It manages log filtering, time stamping, and message structure. It also handles multi-domain logging or cross-domain log transfer. Because, for example, uh, we may have multiple cores and or in one core we have different domain. So the core will handle this, that how this connection work, and then how it goes to the output. Also, uh, Zephyr can handle nine backend at the same time. So the first one that we mostly work with is UART console, RAM buffer, or any other console. Um, uh, but it can happens in the same time. You can read more about multi-domain logging in the Zephyr documents, but it's good for now, and I hope you enjoy this tutorial. And thanks for watching. And please, if you uh, see anything that I need to improve or talk about more, comment. And thanks.